yeah, let's look at these three together then. So first of all, we know when we look at a periodic table, you'll have a mass number and you'll have an atomic number. So, for example, carbon has got a mass number of 12, an atomic number of 6. First of all, by the way, don't worry if the 12 and the 6 are different way around on your periodic table. There's no, I don't know if there is a particular convention, but they often periodic tables switch it around. So the way to remember it is the larger number is the mass number. Always the larger number is the mass number. Always the smaller number is the atomic number. So this is the mass number. So if I said what's the mass number of carbon, easy. You just look at the larger number. It's 12. Now the formula mass is not too hard. It's basically if I wrote CO2 and I said, rather than saying what's the mass number of CO2, well, CO2 isn't on the periodic table, but I can ask you what is the relative formula mass, and you would look at this C, we've got one lots of C, so 12 plus, and there are two lots of oxygen, so we go 2 times, and on the periodic table, when you look at oxygen, you'll find it's 16 and 8. So you go 2 times 16. Now you want to make sure that you are we're using our brackets now in the mathematical way again. We're going to make sure that we're not adding 2 and then timesing it all by 16. So that's going to be 12 plus 32. Oh, come on. 32. Why is it not? Yes, 44. So 44 is the relative formula mass. Okay, that's the relative formula mass. And let's just look at the next point. Show that the relative formula mass of reactants equals relative formula mass of the products. So what's reactants and products? Well, reactants is the stuff on the left. So let's label that on my equation up here. So that is reactants. And the stuff that's being produced is the products. Okay, so what's the relative formula mass of the reactants? Well, so just going to put an R for reactants. Well, if you want to if you could just look at the periodic table and find me the mass number for magnesium, which is in group 2. Is it 24? Okay, that's not the atomic number, that's the mass number, right? Yeah. No, that you're right the first time. It's the larger number is the one. Yeah, so that's okay. So 2 times 24 is the magnesium. So 2 times 24 plus, and then the I know that actually I see if I should be able to remember this one. So plus 2 times, and it's going to be hydrogen plus chlorine. Now hydrogen is 1, and chlorine I believe is 35.5. Can you check that for me? So chlorine is in group 7, halogen. Okay, cool. So reactants is going to be 2 times 24 because of 2 lots of magnesium once we've balanced the equation, and then 2 lots of this. So we got 2 times 24 is 48 plus, and then as you said, 35.5 plus 1 is 36.5. So then we're going to multiply that by 2. What's 36.5 times 2? This is going to be 2 times 36.5. I mean, you get to use a calculator, of course, in science exams anyway. So 73. So that's the relative formula mass of all of them added together on the left-hand side, and then that's the reactants. Then the products is going to be equal to 2 times magnesium plus chlorine. Now you told me already that magnesium was 24, and chlorine is 35.5. and then we've got hydrogen, and we've got 2 lots of hydrogen, so plus 2. So that's going to be equal to 2 times, so what's 24 plus 35.5? We went mental arithmetic. 35, first of all, you add the 20, 59.5, good. So it's going to be 2 times 59.5, and then you're going to add 2. So now we just need to 2 times 59.5, and that's going to be basically, well, 2 times 60 is 120. Then they take away the 0.5 twice, so 120. So 2 times 120. So that's 119 plus the 2. Whoa, what's going on here? I seem to have made a mistake somewhere. Oh, I didn't. Look what I did. I didn't add the 48 at the top. Sorry, 73, and then we. Wait a second. This is what. Yeah. That was a 73, but then of course we've still got to add the 48. So 48 plus 73. Right, so that's 121, and afterwards we've got 119 plus 2, which is equal to 121. So so show that relative form of mass is equal to, yeah, okay. And the last one says explain why some reactants seem to lose, and it says seem to, doesn't actually, but seem to lose or gain mass. And the reason for that is because, well, usually because that gas escapes. Okay, so you'll have, and it might also be because of spillage, or why might it gain mass? Well, that might be, let's say you got an iron nail and it's sitting outside, and then you weigh it after 2 weeks, it will actually be heavier, and that's because it's taken oxygen in from the air, and that's added to the mass. So the oxygen atoms have added to the total mass. So that's what that one is there. So that wraps up those 3.